Hi friends, let's have a look at problem 1980, find unique binary string. This is a daily challenge problem. In this video, our goal is to practice several ideas. One is the bit mask idea, and the other is the traversal idea. And finally, we want to present a one-line solution for this problem. So if we just want to solve this problem, we can write a one-line solution. But our purpose here is to practice coding. So with that said, our plan will be the following. First, we're going to digest the problem requirement, and then we share the code. And in between, we're going to explain the logic. So now let's move to the problem digest. So here we are given an array of strings called nums containing n unique binary strings, each of length n. So here the uniqueness assumption is very important. So we want to return a binary string of length n that does not appear in nums. And if there are multiple answers, we may need to return, we just need to return any of them. So here actually, due to the assumption, right, the solutions actually are non-unique, right? So if you consider n numbers which have n digits in their binary representations, overall we have 2 to the power n variants, right? So here we are given n, right? So that's why 2 to the power n is much larger than n. So we have multiple solutions. So in the smallest case, if n equals 1, so we have one given and we have another one. This is a special case. Thus n is greater than 1, so we have at least 2 solutions. So with that said, let's look at the examples. So in the first example and the second example, we can return 1, 1, right? So you can just screen and explain spots that they are different. So in the third example, the return is 101. So you can also just manually look at it. So here the main constraint is that n is less than or equal to 16. So if we consider all the possibilities of the binary strings of length n, so this is all the possibilities, the total numbers is bounded by 2 to the power 16, which is bounded by, say, roughly 1 million, right? That's actually not very large for leetcode problem size. So with that said, I guess we are ready to look at the coding part. So the logic here is very straightforward. So in the first version, we want to check all the numbers between 0 up to 2 to the power n minus 1. And then we look at their binary representations corresponding to a length n binary string. And we just need to check if the binary string is in the list nums or not, right? So let me first make some annotation. So here this is based on bit mask. First, the nums essentially plays the role of a set because of the uniqueness of elements. So we are going to make it a set. So this is for the ease of membership check. And then we're going to use the bit mask idea. So basically for I in range, so 2 to the power, let me specify an n. This is a length just for convenience, right? So this will span from 0 to 2 to the power n minus 1, both inclusive. And then we can look at the binary representation of the integer I. So here, this is the binary representation, right? Binary I. So we just want to delete the 0b. So we have this one. So notice that in this problem, we want the string to be length n. So we can pad some zeros ahead temp if its length is not enough to n. So we want to do something like this. Let's see, add equals 0 times n is the required length minus the length of temp, right? So we can write something like this. The result will be add plus temp. So the length of this result variable will be n, right? So then what left is to check if result, not in the auxiliary side. So we are going to return this result. So due to the assumption of this problem, so there will always be a return. So we are going to leave the code as it is. So this actually forms a solution format to this problem. So let's do a test. It passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. This will be our solution V1. So now let me copy this part. Let's mark this one as V1. So for the second one, I want to write a solution based on traversal. So we are going to start from 0, so n bit zeros. So basically, let me first specify n. So here I can specify like this. So this is the more precise, even if the length of this nums list is not n. So if we assume all the strings in the nums has length n, so this n will be, I'm going to use 0, nums 0. So you can use nums by this problem, but this is more precise in a sense. So we start from 0, length n 0 strings. And then we also want to make this nums a set. And then we want to do traversal. First, let's get a deck. So here, though we use deck, actually we use its queue behavior, right? So we use this s as a source. And then I want to specify a set. This is for avoiding repetition. So next, we do the while block for standard traversal. So we're going to get the current node. So as pop left. Then we want to check if current not in nums. So we're going to return current. That's it, right? Otherwise, we finished looking at the current. So we add it to the scene set. And then we are going to look at its neighbor. So for this neighbor, what we mean, we can change one of the positions in 0 to be 1, right? So basically for I in range m. So this is the length of the string, right? So for each position, so if si equals 0, so we can do a flip. So let's say temp. So we flip that to be 1, right? And then we do as I plus 1 onwards, right? So let's do another check. If temp not in scene, so this is to avoid repetition, right? So we are going to do append this one. Again, due to the assumption of this problem, this will always give us a solution. So after several rounds, because after all, this nums contains only n elements. So let's do a test. Yeah, it passes the first one. So now let's look at the generic case. So yeah, it passes all the generic cases. So notice that here, here actually we can just here we are using si. Essentially we should use current. But using si is still correct. We'll explain why in the next solution format. Let's test this case. Using current is like a full traversal, right? You get it passes. If you just change this current to s, it will also work. So why it also work if we use s? Let me change back to current, just to make it more aligned with the typical traversal. So I'm going to explain the third solution. You are going to understand why in this traversal we can just change s. I'm going to change this one to be version v1. So for this one, let me first write down the solution and then we explain it. So here I'm going to use a John method. Then we use comprehension. So 1, if nums I, the ith character equals 0. Otherwise, I would make it 0. In other words, we do a flip operation in the ith position in the ith string. If for I in range length nums. So this is the one-line solution. Let's first test it. Yeah, it passes all the cases. So now let me explain this solution. So in other words, for solving this specific problem, we can use this version 3, just one line. But it's important to understand the logic. So here, this is the corresponding to the first third example. We have 1, 1, 1, 0, 1, 1, and 0, 0. So now the method or the solution tells us we need to flip the character, the zeros character for zeros string. So here is a 1. I'm going to flip it to be 0. So after we flip this one, it means that no matter what we choose in the remaining bits of the result, so let's use this as the result, then it will be different from the first one, or the zeros one, because it's already different in the zeros bit, right? So now let's continue. So let's look at the one at index 1. So at index 1, it has a 1, so we're going to flip it to be 0. So this means that no matter what we want to set in the following bits, it's already different from the second one. So up to now, we know once the first two positions are flipped, so the result will for sure be different from the first two. Then similarly, you flip every position, so the result will be the following. The result variable we get will be different from all the n given binary strings. So that's the logic for the third one. So essentially, it's just a one line, or you can call it a greedy solution, but not that rigorous. So basically, we arrange that and use the assumption that the list contains only n unique binary strings. So with that said, I guess that's about it for the third version. And also, it's the end of this video. So if you are interested in practicing more leetcode problem in a systematic way like this, so you are welcome to follow our channel and look at different playlists inside. With that said, thank you.